Comparing two means. Two sample mean t-tests compare the responses of two treatments or two characteristics of two populations. There's a separate sample from each treatment or population. The tests are quite different from our matched pairs t-test, where our samples came from the same population. The null and alternate hypothesis are comparisons between the two means. We need to identify which mean goes with which population. We usually designate them as group 1 and group 2 and use subscripts of 1 and 2 with our means. So our null and alternate will be one of these three exactly. The assumptions for a two-sample mean t-test are: we have two independent simple random samples from two distinct populations. We're measuring the same variables, however, from both samples. Both populations are normally distributed or with unknown means and standard deviations, or we're given that the sample size for each is greater than or equal to 30. The test statistic will look like this. The mean of sample 1 minus the mean of sample 2 minus the mean for population 1 minus the mean for population 2 divided by the square root of S1 squared over N1 plus S2 squared over N2. Note, since our null hypothesis on the test we will be doing will be making a comparison of whether or not these two population means are equal, this value for our test will be 0. The degrees of freedoms that we will use on this t-test will be the smaller of N1 minus 1 or N2 minus 1. So we pick the size of the sample that's smallest, subtract 1 for our degrees of freedom. For example, the president of an all-female school stated in an interview that she was sure the students at her school studied more on average than the students at a neighboring all-male school. The president of the all-male school responded he thought the mean studying time for each student body was undoubtedly the same and suggests that we undertake a study to clear up the controversy. Independent random samples were taken with the following information. So we want to decide at the 2% level of significance if there's a significant difference between the mean studying times. So our H0 will be that the two population means are the same, and our HA will be that they are different. Now let's let our all-female group be group 1 and the all-male group be group 2. This makes N1 65, N2 is 75, X bar 1 18.56, X bar 2 17.95, and this is S1 and S2. Now since we have a not equal, this is a two-tailed test, so I'm going to draw over here my little standard normal curve with both tails shaded. We have an alpha of 0.02, so since we're splitting that into two tails, each tail would be half, 0.01. When I calculate my test statistic, my smaller of these two sample sizes is 65, so we're going to use a degrees of freedom of 65 minus 1, which is 64. So I'm going to use inverse t or QT of 0.01 with 64 degrees of freedom, and that's going to give me negative 2.386, and this one would be 2.386, the positive value. Our test statistic will be X bar 1 minus X bar 2 minus the difference in the population means, which will be 0 since we're assuming them to be the same, divided by the square root of S1 squared over N1 plus S2 squared over N2. This comes out to be positive 0.7827. That value is between 0 and 2.386. I'll plot it right there. It does not fall in my rejection region, so you can see that we're going to fail to reject. Now we need to calculate our p-value for this. I'll do it at the top of the page. Our p-value will be 2 times, since we have 2 tails, the probability that t is, now I have a positive value, so we'll use greater than, again, positive, greater than, negative, less than, 0.7827. And this is going to give me, again, we're going to use a t distribution with 64 degrees of freedom. The probability value here is 0.437, which is greater than our alpha, so we will fail to reject our null hypothesis, which says that there's no difference. Another example. Determine at the 2% significance if there's a difference in the mean studying times on the 2 samples between these 2 groups. Here we have a group of students that have had remediation and some without remediation. Let's let the remedial group be 1 and non-remedial be group 2. So this 100 is N1, here's my X bar 1, and here's my S1, N2, X bar 2, and S2. The smaller of my n's is 40, so my degrees of freedom will be 39. Oops, this example changed the number. Let's change that back to 2%. So test at the 2% level whether the remediation helped the students to be more successful. Okay, our null hypothesis is that there's no difference in these populations. Our alternate is saying that the remedial, which is group 1, is more successful than group 2. Our rejection region would be a one-tailed test, shaded to the right because it's greater than. So this value right here is 0.02. Again, remember we're doing inverse t or QT if you're using RStudio of 0.98 because we always have to do the area to the left, and 39 degrees of freedom. This gives me a test statistic of 2.125. So our t for the test statistic is 83.0 minus 76.5 minus, we're claiming there's no difference in the means, S1 squared over N1 plus S2 squared over N2, and this comes out to be 9.206. 9.206 will be very far to the right in my shaded region, so you can see in the rejection region we will be rejecting. My p-value is the probability that t is greater than, for my alternate hypothesis, 9.206. Here we could use TCDF. This would be my lower bounds. My upper bounds would just be some large number like 10 to the 6, and my degrees of freedom is 39. If I'm using RStudio, we do 1 minus PT of 9.206, 39. Either way, we're going to get 1.26 times 10 to the negative 11, which is about 0. This is less than my alpha of 2%, so we will reject the null hypothesis. Our conclusion would be, based on the 2% level of significance, we will reject the null hypothesis, which says that there's no difference in the means for the remedial and non-remedial, in favor of saying that the remedial has a higher exam.